understand number 1. So on number 2, it's really just a question of rearranging everything. So the reason why I say that is because you really have a negative 15 times x times y to the 4th. Okay? And then you have times a negative 1/3 times x times y to the 3rd. So there's a bunch of multiplication, and commutative property of multiplication allows us to move things around, right? Switch the order. So if you have negative 15 times the negative 1/3, and then let's put this x next. So you can put times x, and then times this other x. We're just rearranging, that's all. And then at the very end, we're going to put the y's. You have y to the 4th times y to the 3rd. So hopefully everybody's jotting this stuff down, especially if you missed this question, because it's very likely it's going to reappear on the test this Thursday. So when we go negative 15 times negative 1/3, that's really, if you want, you could put it over 1 and multiply top with the top and the bottom with the bottom. Now we already know that a negative times a negative is a positive, so you really end up with 15 over 3, and of course 15 divided by 3 is 5. So the first part of your answer will be a 5. And then you have x times x, which is really x squared. Then you have y to the 4th times y to the 3rd. That's going to be y to the 7th. So ladies and gentlemen, please jot that down right there. That's your final answer for number 2. So number 3, it's combining two of the rules of exponents, where you distribute the outside to the inside. Now, how about this negative sign? Let's start by thinking about this whole thing being a negative number. So if you really did have a negative, because it is a negative number, a negative times a negative times a negative. Why am I saying that? Because it's the power of 3. So let's first think about a negative times a negative times a negative. Is your answer going to be positive or negative? Anybody? It's going to be negative, right? So let's put a negative sign on our answer. And I want to, or even another way of doing this, guys, or more clear, you could put the invisible one, you could write it out and write that as a negative 1. And then distribute this outside 3 to each of those terms. So you're really going to have, let me do this, negative 1 to the 3rd. You're going to have x to the 3rd and y to the 3rd. Whoops. So negative 1 to the 3rd power is really negative 1, x to the 3rd, y to the 3rd. Now, of course, we still have this other term right here that we need to multiply by. That's an x times z. So you're just going to bring down that x and bring down that z. And of course, you could still multiply the x to the 3rd times x to get a total of x to the 4th. So your final answer is going to be negative 1, or just negative, x to the 4th, y to the 3rd, z. Now you always want to write, if you have several variables, you want to write them in alphabetical order. Bless you. You don't want to leave it as like a y, z, x. You want to write it as x, y, z. Jump into number 9. Okay, so this is a fraction. If you were to think about negative 21 over 7, if that were just a fraction, what would you get? What's negative 21 over 7? It's negative 3, right? Negative 21 divided by 7 is negative 3. And where does that 3 belong? It belongs up on top, because the 21 was up on top. So you're going to have negative 3 up there. And the w to the 4th on the bottom is going to completely cancel out with the w to the 5 up on top. In other words, you have 4 w's on the bottom that cancel out with 4 of these, and there's only going to be 1 left up on top. So you cancel the 4 with 4 of those, there's going to be 1 left up on top. So you could write that w that's left over up on top next to the 3. And at the very end, we're going to cancel out the x squared that's on top with 2 of the 5 x's on the bottom. So x squared completely cancels out with 2 of these 5, and you'll have 3 left over on the bottom. So you're going to have x to the 3rd left over on the bottom. And ladies and gentlemen, this is it. That's your final answer there. Now that negative sign doesn't have to be up here with the 3. You could put it out here in front of the fraction if you'd like. The only thing, most of the time, if you ever end up with a negative on the bottom, move it to the middle or move it to the top. But I wouldn't leave it on the bottom. But that's not the case here. Okay, so we said number 9. Which other one? 13. What was the rule with negative exponents? What are we supposed to do with negative exponents? Grab it, move it to the other side, right? So if I move that f to the negative 7 down, what's left up on top?
1.
An invisible 1, right? There is nothing left up on top, so we have to put a 1 up there. Now on the bottom, you originally had your f to the 4th, and we said we're bringing down the f to the negative 7, which is going to become f to the positive 7 on the bottom. Okay? Now, Rule 1 of exponents allows us to add the exponents when you're multiplying with the same base. So what's our answer going to be? It's going to be 1 over f to the 11th. So anyways, this is your answer. 1 over f to the 11th. You absolutely need that 1 up there. There's nothing left up there. You have to write the 1. Okay, which other one did you guys want? 18? Nobody on 14 or 15? 16? Yeah, 16? No 16. Which one? 17, somebody said. 17 and 18. Why not? So on 17, we have parentheses with an exponent on the outside. And we're supposed to take that exponent and distribute it to each and every other exponent on the inside. So when I take this negative 4 and distribute it to the negative 1, remember, a power to a power, you really multiply. So let me rewrite this thing. Instead of j to the negative 1, we're going to have a j to the positive 4. Because negative 4 times negative 1 is positive 4. Then when we distribute negative 4 times positive 3, we're going to end up with what? K to the negative 12. Because negative 4 times 3 is negative 12. Now on the bottom, I'm just going to rewrite it for now. J to the 3, K to the 3. And from there, we're going to continue with other rules of exponents. For example, we have that rule that if you have the same thing up on top and bottom, you could cancel out, right? It's kind of like subtracting. There's 4 j's up on top, there's 3 j's on the bottom. 3 of these will cancel out with 3 of these. There's going to be 1 left over. We also have the rule of negative exponents. What do we do with negative exponents? You grab them, you move them to the other side. So what do I have left up on top? I simply have a j, or a j to the 1. And I originally had a k to the 3rd on the bottom. And that k to the negative 12, when I move it down, it's going to become k to the positive 12. So our final answer will be j up on top over k to the 15th power. Any questions on that? Moving on to number 18. Again, you have parentheses with an exponent on the outside, and you're going to take that outside exponent and distribute it to each and every exponent on the inside. Now remember, the q actually has a power of 1 right there. So you're going to take that negative 5 and put that times negative 1 times 3 times 1 times negative 2. So that's one option of doing it that way, distributing the negative 5 to each of the terms. Another option is to look at the inside and see if you could do anything with the inside before distributing. So you could move the q down, move the r up, or you could just distribute. Either way is probably equally as easy. I'm going to distribute that outside negative 5, distribute it there, there, right there, and right there. Okay? So I'm going to have a new fraction. It's going to be q to the what? Q to the 5, because negative 1 times negative 5 is 5. R to the what? Negative 15. On the bottom, q to the what? Negative 5. and the r to the what? Positive 10. Okay, so what I want to do is move the negative exponent terms to the other side to make them positive. This r to the negative 15 is going to come down right next to the r to the 10. This q to the negative 5 is going to go right up in front of the q to the 5. So I'm really going to have a q to the positive 5 times q to the positive 5, the original one that was up there. And that r to the 10th that's on the bottom is still going to be right there, r to the 10th. But the r to the negative 15th, I want to move it down right next to it, and it's going to become r to the positive 15th. So what do I really have left over up on top? What do I have? Q to the what? Q to the 5th times Q to the 5th. Q to the 10th. And on the bottom, r to the 10th times r to the 15th. R to the 25th. And there's your answer for number 18. Which other one? 20? 20. The fun one. Okay. So there are many different ways of doing this problem. Let's first look on the inside of the parentheses. Let's zoom in completely, and let's see if there's anything we could do in those parentheses. For example, the 9 and the 18. 18 on top over 9 on the bottom, you're going to have a coefficient of 2 left over, because 18 divided by 2 is 9, and it's left over up on top. What else could I do? X to the 0, that is 1, so I could just scratch it out. Okay? What else am I going to do? I'm going to take this x to the negative 2, and I'm going to move it up. I mean, x to the 0 is gone, but now I'm going to put an x to the 2 up there. Not only that, I have one y on the bottom, and I have y to the 3 up on top. So this y down here cancels out with one of these 3, and you're going to have 2 left over up on top. And for the z's, I have 9 z's up on the top and 14 z's on the bottom. So 9 z's cancel out with 9 of these, and you're going to have 5 z's left over on the bottom. So far, let me rewrite this thing. Here are my parentheses. Here's my fraction bar. I have a 2 up on top. I have a y to the 2nd up on top. Oh, I forgot the x to the 2nd that got moved from the bottom. The x to the negative 2 got moved up, and it becomes x to the positive 2. And that's about it. On the bottom, the only thing I have is the z to the 5th. So there's my fraction, 2x squared y squared. And if we zoom out a little, we'll see that you still have the power of negative 2 and then power of negative 3. What do we do when we have a power to a power? What do we do with these guys when you have a power to a power? Come on, guys. What do you do? You multiply them, right? Power to a power, you multiply. So negative 2 times negative 3 is what? Positive 6. So we really have the power of 6 instead of the power of negative 2 and the power of negative 3. So what we really have is this situation where I need to take this 6 and put them on each of the exponents on the inside. So I'm really going to have 2 to the 6th power, x to the 12th power, y to the 12th power, over z to the 30th power. So that's our answer. However, we could do 2 to the 6th. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So our best answer would be 64, x to the 12th, y to the 12th, over z to the 30th. Ta-da! I hope that helps. Guys, all these questions are going to pop out again on the test that we're going to have Thursday. Okay, we're going to have this test Thursday. That's the day after tomorrow, because today's Tuesday. All right, so there's really nothing else to cover. We're just going to keep practicing today, tomorrow, and then we're going to have a test on this stuff Thursday. It's your last chance to bump up your scores when it comes to dealing with this section on exponents.